So in this question, we have blue liquid dinitrogen trioxide, which is N2O3, reacting with 2NaOH to form sodium nitrite. And the question is, if 14.5 grams of dinitrogen trioxide is added to a certain amount of sodium hydroxide, determine the mass of sodium nitrite produced. The way the question looks like, it seems like it has two knowns. This is one known, right? That is, you can use this to find the moles of dinitrogen dioxide, and that's the other known, which is the volume and concentration of sodium hydroxide. And so the goal is to find the moles of both knowns and then see which one is in excess. So step number one is just finding the moles of both knowns, known 1 and known 2. So for known 1, you'll have to find the moles of N2O3. For that, you need the MR of N2O3, which is 76. And so the number of moles is mass over molar mass, and the mass is 14.5 grams over MR, or molar mass, is 76. So 14.5 over 76. This gives you the moles of N2O3, which happen to be 0.1908 moles of N2O3. Now we go on to finding the moles of NaOH, whose volume and concentration we have been given. So number of moles is concentration into volume. Concentration is 22.31 into volume is 35 over 1,000. And this gives you the moles of NaOH, which happen to be 0.08085 moles of NaOH. So now you have the moles of both your knowns, NaOH and N2O3. Now we're going to use the equation ratio 1:2 to find which of the two knowns is in excess. That's step number 2A. Before we figure out which known is in excess and which known is limiting. So either we take how many moles will 0.1908 react with N2O3, or the other way. You can start off with either or. All you really need is to use the ratio of known 1 is to known 2. And you can start off with N2O3 and find out how many moles of NaOH you need, or start off with NaOH and find out how many moles of N2O3 you need. Since it's on the left, I'll start with N2O3. So the ratio from the equation, by the way, of N2O3 and NaOH is the coefficients are 1:2. So let's find out how many moles of NaOH will react with 0.1902 moles of N2O3. Ratio 1:2, cross multiply. You get the value for X as 0.3816 moles of NaOH. So ratio is 1:2, that's why. But I only have 0.08085. But I need 0.38, which really tells me that NaOH is the limiting moles, because 0.1908 needs 0.38. 0.1908 needs 0.3816, but I only have 0.0805. So I have less than what I need. So therefore NaOH is limiting, which means that now the moles of NaOH is my limiting known, and that's the one I use for part B. So NaOH is limiting known. That's the one I use. That means N2O3 was excess. Something that's an excess is not needed for the calculation. So now I'm going to use the ratio between NaOH and my unknown. And what's my unknown? The mass of sodium nitrite. That's what I need to find, right? So how do I find that? Well, the ratio of the equation is 1:1. So I've got to find the moles of NaNO2 first. So the ratio of NaOH to NaNO2 is what I use. So step number 2B is the ratio of the limiting known to the unknown. So limiting known to the unknown. Limiting known is NaOH, and and the unknown is NaNO2. And their coefficients really are 2:2, which really means what? 1:1. So look at the equation, 2:2, right? So 1:1. And then I just plug in the relationship in this ratio, right? So 2:2, 1:1. And how many moles of NaOH do I have? I have limited 0.8085 is to X, not 0.38. That's excess. That I didn't have that. I only really had 0.08085. And this tells me I will make 0.08085 moles of NaNO2. And now I have more moles of my unknown now. And step 3 would mean converting these moles of the unknown to what? to the amount you need, which is the mass. So how do I find mass? In this case, number of moles is mass over molar mass, and I need the molar mass of NaNO2. So I need the MR of NaNO2, or the formula mass, which happens to be 69. So the number of moles is basically mass over molar mass. And what mass do I get? What is the number of moles? 0.08085, mass over 69. And then I cross multiply and I get the value for M, which is 5.578 grams. So this rounds out to 5.58 grams of NaNO2. Yeah.